Hi and welcome to AD.ACADEMY. In this video we are going to learn how to draw a block diagram for this kind of a very simple RC circuit. And as we know that RC circuit means the circuit that consists of a resistor and a capacitor, which we can see that's called the resistor and that is our capacitor. Now as we can see here, we have applied the voltages across resistor and a capacitor, and which is known as V in, and we are having an output across a capacitor which named as V out. And we know that the voltage drop across the resistor will be known as VR, and the voltage drop across the capacitor will be known as VC. Now as we can see, the current will go in this direction, which name is I, and if the current is going in this direction, then the voltage across the resistor and the capacitor will be in the opposite direction, which is this direction. So let's draw the direction of the voltages here, and they are going in this direction and in this direction. Now first of all, in order to draw the block diagram, we have to first figure it out the few equations and the terms, which is our VR, VC and the total voltages. So the things that we have to find out are V total, VR, which is the voltage drop across the resistor, and the VC, which is the voltage drop across the capacitor. So let's jump on the first equation, which is V total. As we know, V total is equals to the V in, and we know the V in is equals to the voltage drop across the resistor plus the voltage drop across the capacitor. And let's rewrite this equation and give it a name, equation number 1. VR plus VC, and this is our equation number 1. So we are done with equation number 1, which is V total. Now we have to jump on VR. From Ohm's law, as we know that Ohm's law states that V equals to IR, which means the voltages are the product of a current and the resistor. We know R is equals to V over I, and I equals to V over R. Now as we know that the voltage across the resistor, which is here, will be determined as V equals to IR. So if we just take that equation and say VR, this R represents the name of the component across which we are trying to find out the voltages. So VR is equals to I times R. I is the current and R is the amount of the resistance, which is always in ohms. So we got our second equation done as well, and let's give this equation number 2, and we're done with this one. Now the third one is VC. So directly we don't have any formula to find out the voltages across the capacitor. However, we got a one formula, which is a formula of a charge, and we know CHARG, charge is equals to Q equals to CV, capacitance times the velocity. Now what is a capacitance? The ability of a capacitor to store the charge inside the capacitor is called the capacitance. Alright, and if we wanna, so now here one more thing, because here V is representing the voltages across the capacitor, so we can, for our ease, we can say these voltages are the voltages of a capacitor. So if we want to find out the voltages across the capacitor, so let's make VC as our subject and make Q times 1 over C. Now in control system engineering, we cannot use Q as straight away. We have to turn this Q into the integral part, and as we know, Q is equals to integration of a current with respect to time. So in this original formula, we can replace Q with this, and we will have Q, which means we can say VC is equals to 1 on C I dt. Now I'm going to rewrite this equation here, and I'm going to say VC equals to 1 over C integration of a current with respect to time. Now we got our third equation ready as well, and we have all these all the equations which are more than enough to draw the block diagram. So let's keep these equations here which we're gonna use. I'm just gonna underline them so it's much easier for you guys to understand what we're doing. So we'll be using equation number 1, equation number 2, and equation number 3, which are underlined, and I'm just going to put an arrow as well. So these are the equations that we have to draw. Now we know from our previous knowledge of electronics, and we know if I integrate current, I will having a charge in my output, and if I multiply this charge with 1 on C, it will give me a result of a VC. Now what this block actually means is Q times 1 over C is equals to VC. Now that particular block is related to this formula. All right, and I'm just gonna remove this, or let's keep this one as well. And as we got our current here, now we know this I is being taken from the Ohm's law, which is V equals to IR, and if I just make I as a subject, R, it means V times 1 over R, and definitely these voltages are VR equal VR times 1 over R. So if I just put this block here and say it is 1 over R, which is having an input of VR. Now we got our VR here, which is being taken from equation number 1, which is over here, in which V in is our subject, and which is equals to VR plus VC. And if I want to make VR as a subject, I can rewrite this equation and can have VR equals to V in minus VC, which means a sum of two different kind of voltages. So I'm gonna have a summation block here. I'm gonna send a V in, which is positive, and negative VC, which means VC is over here, and we can just send a negative feedback into this block diagram, and we are done. Just remember that this is our output, because we are having an output across a capacitor, so always make sure that you are giving a right outlet for your output according to the circuit diagram that's been given to you, and this would be our input section, and that's our output section. So guys, that's how it was easy to draw the block diagram for a very simple electronic circuit. And thank you very much for watching my video, and also thank you very much for your support, and please like, subscribe and comment on my channel, and if there is anything I can do to make these videos better for you, so you can have a better understanding, please give me a feedback and leave your comment in the comment section, and please share this video with your friends and fellow, and I will see you in the next video.